Ever wondered how your GPS knows exactly where you are? Or how skateboard ramps, roads, and roller coasters all have the perfect angle? Well, it's all about this one thing: slope, the secret language of lines that tells us how steep or flat something really is. Welcome to Module 8, the coordinate plane and slope. Today, we'll explore how to plot points, find slopes, and unlock the geometry behind motion, design, and direction. By the end, you'll know how to plot points like a pro, spot parallel and perpendicular lines instantly, and calculate the slope even from the real world examples. So grab your pen and paper, get ready to rise and run, and let's make math come alive, right here in Module 8. Run itself. So if you guys remember, we were talking about different kind of slope. We were talking about the slight slope, we were talking about fast slope, we were talking about zero and also undefined. So right now we are going to visualize it and actually see in our formula what does that mean. So the very first one is about the zero slope. By the way, when we do have m as 0, it means that we are talking about the flat line. If I want to show you in the formula itself, y subtracted by y1 is equals m times x subtracted by x1. It means that at this point when m is 0, this part is gone and y is equals to y1. It means that it doesn't matter how much you're changing. At the end, your parentheses multiplied by m is going to be 0, so your y is going to stay at y1 or sit at the first point all the time. It's not going to change at all. So this is something that we call as a zero slope. And again, in the formula itself, you can see that your y, if you use it on that part, on another one, on mx plus b, since your m is 0, your y is going to be a constant number. On another hand, we do have undefined one. It means that x is not going to change at all, and it's going to be r. If the x changes, it is going to be so fast for y, which is not going to be usable for us. And the equation itself is just x all equals to a itself. It means that x is just a constant number. By the way, one thing that I guess it's worth mentioning over here is that sometimes you do have some kind of equations, and those equations are a little bit weird. What does that mean? Imagine that, I do have some kind of equation related to a line like this. X is equals to 2. So you're telling by yourself that what does that mean? It is so unclear. I don't have any y, I don't have any slope, I don't have anything. So when you have something like this, the only thing you have to do is just move 2 to the right, and after that, draw this one. I'm sorry, it's not some kind of straight line, but this is a line. It means that this guy is showing you a line, still a line, that is y is going to change all the time, but its x is going to be 2 all the time. On another hand, we do have another one. Y is equals to 3, for example. What does that mean? It means that you only have to move to the top y, and after that, you do have this line. It means that despite of the fact that x is changing all the time, your y is going to be constant all the time. So let's have a small lab together. Let's just look at this question and talk about it. I do have a point. I do have the slope. After that, I'm trying to design a line itself. So how I can do that, or how I can draw the line? The first point is -1 and 2, and the slope is -3 over 4. How I can do that is simple. First of all, start for -1 and 2. It means that this is my initial point. I have to find out that what is the line, or how I can draw the line. -1 and 2 is my first point. After that one, I have to move to the right with 4 units. It means that I have to move to the right with 4 units. Why 4, by the way? Because if you guys remember, talking about the slope was delta y over delta x. So when we do have -3 over 4, or we can write it down as -3 over 4, or we write it down as 3 over -4, doesn't matter. Well, all of them are the same. So we assume that we are talking about this. It means that if I move to the right with 4 units, I have to move to the bottom with -3 or 3 units. So at this point, I'm moving to the right with 4 units, moving down with 3 units. So if I do that, I do have something like this. -3 or 3 to the down. So I will find a point. At this point, my point is going to be 3 and -1 itself. So right now, I do have my 2 lines, and I do have 2 points, and I can draw it through the first point and the second point itself. As simple as that. So imagine that I do have 2 points, and after that I have to write an equation related to that, right? I know the first point is -3 and 4, the second point is 5 and -2. So if we remember about the equation, it was y subtracted by y1 is equals m times x subtracted by x1. I have to find the relationship between y and x. Is that so? First of all, let's understand what do we have. I do have this -3, x1, y1, x2, y2. After that, I have to find the slope. Is delta y over delta x, right? Is 2 subtracted by 1 divided by 2 subtracted by x1. So I know from those numbers, my y2 is -2, my y1 is 4, my x2 is 5, and my y1 is -3. So if I do that, it would be -6 over 8, just like the example that we had at the beginning of this part, -3 over 4 itself, right? So this is my some kind of slope itself. So at this point, I do have something like this. I have to fix something about that. Sorry, guys. Because if you guys remember from our very first example, I had a question and I talked about it. This part. This one is going to be actually -3 over 4, not -3 over 2. So that was my bad. So right now I do have something as this part, -3 over 4. So right now I found my m. So the only thing that I have to do, I have to put it over here. It's going to be y subtracted by y1. What was my y1? Y1 was 4 is equals -3 over 4 times x subtracted by x1, which my x1 was -3 itself, or I can write it down like this, right? So right now I'm trying to make it a little bit better because it's a little bit ugly right now. So you can multiply both sides by 4 in order to get rid of that. Or for some of you say that we don't want to do that, you can just keep that as the way it is and move 4 to the right. And after that, you can find something like this. Because most of the time, the one important equation that you're looking for should be like this. So if we do that, it would be like that one. I do have -3 over 4, so I can write it down as y subtracted by 4 is equals -3 over 4 times x, and -3 over 4 times this one is going to be what? It's going to be -9 over 4 itself. So if I move 4 to the right, it means that we have to add both sides by +4 itself. It will be -3 over 4x subtracted by 9 over 4 plus 4 itself. So if you just find that one, it would be, we have to find the least common denominator or common denominator. So 4 would be converted to 16 over 4. We do have 16 over 4 subtracted by 9 over 4, which is going to be 7 over 4. So at the end, my y would be -3 over 4x plus 7 over 4 itself. And this is my final number. I do have a slope. I do have my intersection. It means that this is the intersection with the line itself or the y-axis itself. As you can see, it's 7 over 4. And after that, I do have my y itself. Right now, I can find whatever number that or whatever point that I need, as long as I know either x or y itself. Simple as that. So this is some kind of a matching game. As you can see over here at the first point, I do have a very light slope. It means that it's gently rising line with slope approximately is about 0.333 or 1 over 3. After that, we do have the slipping falling line with the slope of negative. By the way, when we have a line like this, means that the slope is positive, the rise over run is positive, and when we do have it like that, it means that the rise over run is negative. So this guy, the slope is negative. On another hand, as I just told you, if you have a condition that your y is going to be the same, but x is changing, means that your slope is 0. On another hand, if you have a condition that your x is not changing, but y is changing a lot of times, or you do have something that we call it as a slope as undefined itself. So again, we can talk about the real world example. When we are talking about the hiking trail map, we are talking about, for example, the positive 200 meter elevation per 1 kilometer. It means that rise over run. When you're talking about the saving growth, it means that $15 added to saving each week is going to be $50 per week. After that, we do have the cooling curve. It means that temperature dropping at 0.8 degrees each minute itself. So we do have it as negative number. We do have it like this, and we do have it like that. So this is the very good example for you guys to know that rise over run not all the time going to be the unitless. It means that sometimes it had units. At what time? Those times that your rise is going to has a different unit with your run. So after that, we do have some kind of the parallel and perpendicular example. So let's talk about this one. Imagine that I give you a line that this equation is y is equals to 2x plus 5. And find a line through the point 1 and negative 3 that is parallel to L1. So how I can do that? Simple. I know when we are talking about two parallel numbers, we are talking about two lines that they do have the same some kind of slope itself. So at this point my slope was 2 because we know y is mx plus b. So I know for a fact that the second one slope is going to be m itself. But at this point I know for a fact that the line should follow 1 and negative 3. It should pass through 1 and negative 3. So if you guys remember from the last formula, y subtracted by y1 is equals m times x subtracted by x1. What is my y1 right now? My y1 is negative 3. What is my slope? Is 2. X subtracted by x1 is 1. So if you simplify this guy, you do have something like this. Y plus 3 is equals 2x minus 2. I just got rid of parentheses, by the way, multiplied by this guy and this guy by that one. So if I subtract 3 from both sides, I do have y is equals 2x subtracted by 2 subtracted by 3, which means that y is 2x minus 5. So right now, as you can see, the slope of these two guys are the same, but this one has different intersection with y-axis with this one. On the other hand, I do have a line that it's equals y is negative 3 over 2x plus 1 itself. So I would like to find another line that goes through 4 and 0 and the same time should be perpendicular to this one. So how I can find the perpendicular right away? I know for a fact that negative 3 over 2 multiplied by whatever number is that. For example, m should be what? Negative 1. If you solve this one, you can find out that your m should be 2 over 3 itself. So my new slope is going to be 2 over 3. It means that y subtracted by y1 equals m times x subtracted by x1. Y subtracted, I know for a fact, is going to pass this line. 0 is equal to 2 over 3 times x minus x1, which for itself. If you simplify this one, you can find something like this, as simple as that. So we do have a common mistake. Again, when we are talking about the slope, please be careful that you can either use one of those ones as your first one, another one as second one, or you can just change their places. But be careful when you're changing that, you're not confusing it with x1, y1, x2, and y2. Another thing that you have to be careful is dividing by 0. It means that when you have a dividing by 0, or your x is not changing, but y is changing so much, we just call it as undefined. Please be careful when you're talking about the real life slope. You're not forgetting about the units itself, because that's a very important part. And also when we do have the parallel, means that the slopes are the same, and we have to make sure that we completely understand it and we know the difference between the parallel and perpendicular itself. So the summary. In this module, we were talking about the slope. We were talking about what does that mean actually. We used a very simple formula for that. And we saw that how we can draw the line while we do have 2 points, how we can some kind of find point when we do have equation for that. We saw the difference between the parallel and perpendicular, and we saw some real life examples of rise over run, and we saw that not all the time we are going to have the same units, or it means that our slope is going to be unitless. We saw 2 examples that how we can find another number based on the definition or based on the question, based on the desired thing that the question has from the first one. For instance, I do have the parallel line. I know for a fact that another line is going to be parallel with the first one. They should have the same, but probably their intersection or the y or that b is going to be different from first one to the next one. And also we had the perpendicular one, means that when you multiply the first slope, the m1 by m2, you should have a negative number, and that was it. So thank you guys for being here with this module. Again, if you have any problem related to that, just comment me down below. I try to explain it, and if I couldn't, I will probably make another video for you. Please share and comment for me. That would be so helpful. Thank you for being here today. My name is Mahmoud Kiosari, and this is Special K. Have yourself a great day, night, whatever. See you around.